So now we have to work backwards. We have to say to ourselves, what would have to have happened? This is back on page 533, example 2. What can we determine from the graph that's already been made? Can you find the center line? Can you find what the amplitude is? Can you find the period? Well, we know that its maximum is 6 and its minimum is -4. What is the distance from the maximum to the minimum then in total? 10. Half of that will be your amplitude. Does it make sense that your amplitude's going to be 5? Then if it's 5, our center line is at 1. Now, just like we had a formula that period was 2 pi over b, if you rearrange that formula, you know that your b value is going to be 2 pi over your period. In order to figure out your period, you need to find out how long it takes for this to repeat itself. Often what people will do is they'll use a maximum or a minimum, if that's on their graph. So if I look on this graph, I can see that I have 2 minimums. How far is it from here to here? Why can't I just say it's 1, 2, 3, 4, 5, 6, 7, 8? I counted 8 little squares. We have to use the scale that's given, right? So what is one of these little squares on our scale? Pi over 12. And if I counted 8 of those squares, does that make sense that that distance is 8 pi over 12? So that's one way you could look at this. You could say, well, I counted those squares, and there's 8 of them, and one of those squares was pi over 12, so then I would know that my period is 8 pi over 12. It doesn't really help us to start here and try to figure out where it's, start right at 0, because it's not a nice value. But the minimum value is a very nice one. Another one you could have used was somewhere where it's starting on your sinusoidal axis in the middle. Here it's in the middle going down, so I can't just go to the next place it's in the middle, because that's not a full period. I have to go again to where it's in the middle going down. Again, if I count the squares, 1, 2, 3, 4, 5, 6, 7, 8, and each square is pi over 12, that gives me 8 pi over 12. Simplifying this, well, dividing by a fraction is same as multiplying by a reciprocal, so I'd have 2 pi over 1 multiplied by 12 over 8 pi. Simplifying this, you get 3. So our b value is 3. Now, yes? So pi over 12, because from here to here is pi over 6, half of pi over 6 would be pi over 12. So then I knew that one space was pi over 12, and I counted 8 spaces here. You could have also, from this diagram, said, well, I know that 2 spaces is pi over 6. So I could have counted by 2's. 1, 2, 3, 4 pi over 6 as a period. It would be the same thing. And if you think 8 pi over 12 does reduce to 4 pi over 6, it reduces to 2 pi over 3. So if you counted pi over 3's, which is 4 spaces, you would need 2 of them to get your whole period. Now finally, in these kind of questions, they say write an equation. They're not saying write the equation, because there's more than one right equation. We're going to start with the most typical one that students would do, but then we're going to look at other possibilities that we could write, why there are an infinite amount of right answers for this question. Now, the most typical one is thinking about our sine graph and saying to ourselves, well, where does sine normally start? It starts in the middle. Starts in the middle going up. Do we have a point on here that's starting in the middle going up somewhere? Yes. Can you see right there? That's where the graph is on your sinusoidal axis and going up. So how did it get there? It would have had to move to the right. So if our c value is moving to the right, how far would we have had to move to the right? 1, 2, 3 pi over 12. So our c value has to show 3 pi over 12 to the right. So now that we've got our d value, our a value, our b value, and we figured out that in order for it to be a sine graph, it would have to move 3 pi over 12 to the right, and you could reduce that to pi over 4, you can now write your equation. Your equation is going to look like this. Y equals, a is 5, sine, b value is 3, bracket, x. Now in order to go to the right, should this be plus or minus? Minus pi over 4, which is the same as 3 pi over 12, and then our d value is plus 1. You could write 3 pi over 12, and that would be perfectly fine. So that would be the most typical equation. But that's choosing this as our starting point, because our starting point is in the middle going up. Do you see any other points on this graph where it's in the middle going up? Yes, way over here. It could have been moved a lot further to the right. If you did this, you would have everything the same. 5 sine 3 x. But now instead of minusing 3 pi over 12, if we count it out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 12 to the right, that would be another one that would work. Can you see why most students would pick the first one over the second one? It's less counting, it's closer, it's less of a movement, but both of those would be right. Okay? Now, sine graphs also sometimes start in the middle going down. Do we have any of those points? Sure, we could have said, well, I'm going to take this point when it's going down. Well, what has to happen for it to go down to begin with? It has to have flipped. So now my equation still has an amplitude of 5, but I have a negative in front to show that it's going down to begin with. B value is still 3, but now it's been shifted pi over 12 to the left. So I could show that by going plus pi over 12. And I still have plus 1 at the end. Is there another one that we could do the same thing? Yes. You could figure out another equation by going to this one. And then if you wanted to draw your graph some more, you could figure out another one. So we could keep going and figuring out all sorts of ones. And anytime, now this question said, in terms of sine, we could have also made this a cos graph. Because sine and cos graphs look the same, it's just where you decide where their starting point is. So the d, the a, and the b will be exactly the same for sine or cos. But if this question said, determine it in terms of cos, well, where does cos start? Cos starts at a maximum. So we could find our first maximum point right up there. And then you would make your cos graph, y equals 5 cos 3x minus, and then you'd figure out this is 1, 2, 3, 4, 5 pi over 12 to the right, x minus 5 pi over 12, and still plus 1. So the only thing that changes is that c value, depending on what you've decided to be your starting point. If you wanted to make it a negative cos graph, you could have started at a minimum. In fact, If you have a choice between a sine and a cos graph, I find that I prefer picking a cos graph because it's often really easy to find a maximum, whereas the sinusoidal axis in the middle going up sometimes gets sort of lost in there because it's in the middle of your graph. But finding a maximum or a minimum really shows up easier on your graph. So sometimes it's easier to write an equation in terms of cos than it is in terms of sine. So your questions are 4, 5, 6, and 7. Ooh, I should become left-handed.